So I welcome you for the session 1 of our day 2 in the FDP on Agentic AI. Today we are privileged to have Dr. Anukriti Bansal with us. She has completed her PhD in image processing and machine learning from IIT Delhi. She has also served as an assistant professor and assistant dean at the LNMNIT and also currently working as a data scientist at LUMIQ. Her area of expertise include machine learning, deep learning, and image processing. She has published several quality research papers in reputed journals and conferences. We are delighted to welcome her on this FDP session and are confident that her knowledge and industry academy experience will provide valuable learning to all the participants. A very warm welcome you, ma'am.
Yeah, thank you so much. Um, so shall we
Yes, ma'am, you
start?
can. Yes, ma'am, you can continue.
So can someone tell me if my screen is visible?
Yes, visible, ma'am. Yeah, we can start now.
Okay, thank you so much. So before I start, I would like to thank Dr. Mahipal for providing me the opportunity. And this is the basic outline. We will first start with a basic understanding of what is generative AI, how large language models work, what is the basic architecture behind these large language models. And then we will see how to use these large language models. What do we understand by prompt? How can we design prompt? And after this session, if you want, if you are eager to do some prompt engineering, design some own application, design an application on your own. I also show you a small demo where how to get the API keys and how to integrate those keys in your Google Colab, and then how to start building an application. So, if you have any doubts, please let me know. Please interrupt me in between, and so that this session can be of any use to you. So this is the basic outline. Let's start with the basic. And before we start with generative AI, let's understand how things used to work before this AI kind of thing. And then only we will be able to understand what is the correct meaning of generative AI and what do we understand by these large language models? What is the need of these large language models? So if I talk about traditional approach, so this is my input. This could be anything. This could be a picture of apple. This could be a picture of banana, any fruit, any object of anything. So in traditional approach, what we used to do, we used to have an input and we used to design some handcrafted features. These handcrafted features uh, could be your aspect ratio, could be texture, color, anything. Once we have these features, we used to design some handcrafted algorithm. What do we understand by handcrafted algorithm? Simple if else statement. If the width by height ratio is almost equal to 1, color is red, texture is smooth, then maybe the fruit is apple. If the aspect ratio is very less than 1 or greater than 1, then maybe and color is yellow, maybe the fruit is banana. So these are the handcrafted algorithm, and based on these handcrafted algorithm we used to provide the output. So this is a basic example. So I have this color and aspect ratio, and based on these two features I would be able to classify them as apple or banana. It was working good. But what will happen if I have another fruit, guava? If I say, okay, guava has similar aspect ratio, if I take the width by height ratio, it is similar to my apple. Color, if I say it is green, apple is red, but we have green apples also. So the color is also not very distinguished property attribute by which I will be able to distinguish between apple and guava. Then there is a third feature. Okay, the texture of guava is not so smooth. Texture of apple is smooth. So maybe this can be one of the features which I can use. So I need another feature, third feature. Maybe add some another fruit. I have to redesign these algorithm, these steps, if else statements, altogether. So this approach was not very scalable. Everything is manual. Whatever domain expert you have, you can apply it. But as soon as some new condition, new use case appears, it may or may not work. So this is one of the examples. I hope you all are aware of this, but just to give a basic understanding, I'm assuming that maybe some of you have zero background or very less background. So this is a basic example. Suppose these are my, what do we understand by features? So these are three varieties of iris flowers. One is setosa. And how we distinguish between these three varieties of iris flower based on the sepal and petal length. So petal length is this, the violet color, and sepal is your green part. So this is your sepal, and these are your petal lengths. And based on these dimensions, we used to distinguish them whether this is setosa, versicolor, virginia, and so on and so forth. And I will write, if it is a traditional approach, I will write, okay, if sepal length is in this range, petal length is in this range, width is in this range, then it will be maybe setosa or versicolor. So this is not very scalable approach. Then we had machine learning approaches, all like your SVMs, logistic regression, naive Bayes. In this, we are designing handcrafted algorithm, but we have automated these algorithm. We are not writing handcrafted rules, but we are designing, we are applying some model that will understand the correlationship between the features and the label. So it will understand, okay, if these are the dimensions of sepal and petal, I don't have to write my own if else statements. It will understand the correlationship between features and the labels. So this was machine learning. It is okay, but again, the problem was I have to have a lot amount of data. When we talk about objects in real world, there can be hundreds and 200 to thousands of classes, and for thousands of classes, I don't know how many features would be sufficient. So though this part was automated, the algorithm part was automated, still features I have to extract, and that was the bottleneck, because I don't know how many features would be sufficient and what features would be uh, important for classification of different objects. So then came the deep learning. Here, feature extraction part was also automated. You just have to provide the labeled data of different objects. It will automatically extract the features. It will understand the correlationship between features and the class, and then give you the output. So this deep learning approaches are very, very scalable, because we don't have to do feature engineering on our own. Then comes, so till 2020, 2014, 15, maybe 16 also, these were all the state of the art algorithms, whether in language processing, whether in computer vision, all the major state of the art algorithm was deep learning based. Then in 2017 came the generative AI algorithms. We had some generative AI algorithms earlier as well, but they were not so popular. The breakthrough come in 2017. We will talk more about it. But what do we understand by generative AI? We can understand this with a simple example. Like we have just seen in traditional approaches, if I have to specify whether this is a cat or not, I have to write the features, that type is animal, legs are 2, ears 2, fur yes, then maybe this is my cat. In deep learning, I will show this is cat, this is not cat, this is cat, this is not cat. Okay, so I will show the images, it will extract the features on its own, and it will provide me the class. It is good, deep learning algorithms are good, but data annotation was a problem. I need a labeled data. I need so many examples of different objects, plus I need to annotate those examples. I need to provide them beforehand. I need to provide a label data. Like these are the images and this is the class. These are the images of these are 10 images and this is the class, means this is the object we want to identify. So label data was a problem if we want to scale it further. Then comes the generative AI. I just provide us it a huge examples, huge amount of information, maybe images, maybe text, and model will automatically understand and it will give me the description of cat. Okay. So generative AI models, they are used to generate the content. These content can be text. I mean, you, as per your question, they can generate the text, they can generate images, they can generate audio, and they are multimodal models as well, which can generate text, which can understand text and images and generate both these modalities or different modalities altogether. So if I talk about language models, Gemini, Claude, these are language. Some of the models are maybe supporting only language, some small language models, some lighter version, they are supporting language only, and some are the multimodal models as well. Now, once we understand the generative AI, let's focus. This is a very basic definition of large language models, but we will talk more about it in detail. But what do we understand by large language models? So in a very simple language, if I have to explain it, so it is a very smart next word predictor. You can consider it large language models. So given a sequence, it will be able to predict the next word. How they are able to predict these next word? Because large language model, they can be considered as a very large neural network, a very complex neural network, which has been trained on such very huge amount of data, has so many parameters and has been trained on large amount of data. I always give a very simple example or classic example in understanding large language models, that maybe from our childhood till now, maybe we have read hundreds and thousands of books, and based on those books, maybe the content of those books, I understand the relationship between different characters in word if they come in sequence. Suppose I say the first word is I. So out of so many words we have, the most of the time, 90% of the time, after I, M will come. I am. So this is how we have learned. If first character is E, second character is Q, out of those 26 alphabet, highest probability will be of U. Most of the time, in so many words, U comes if we have a sequence starting with E and Q. So equation, equilibrium, equal. So in all these, so by having these understanding, we are able to understand the language. Similarly, these models have been trained on large amount of data, so they understand the correlationship between different words. So suppose I give it a sequence of some words, it's raining cats and. So it has a vocabulary. Maybe the vocabulary, the size of the vocabulary is 2 lakhs. So the vocabulary contain 2 lakhs word. It will assign a probability score to all those 2 lakh words. And most cases, if I consider greedy sampling, so it will pick the word which has the highest probability. So these are some of the words from my vocabulary. Out of those 2 lakhs words, these are some 5 words which I have written here. And it has assigned some probability score to all these words. Like winds has received 0 probability, fish has received 0.1 probability, and the highest probability is of dogs. So it will predict dogs. Now input will become it's raining cats and dogs, and same thing will repeat. Like it will again assign probability to all those 2 lakh words and pick the word which has highest probability. So if, and how it is doing this, because if I say this is a huge neural network which has been trained on large amount of data, and this data can be your Wikipedia pages. So much information, so much text they have been fed into, and they have been trained using Wikipedia pages, English textbooks, some different languages textbooks as well. So they are able to understand the language properly. So if my large language model is trained on poem related data, it will be able to generate few lines of poems. If my large language model has been trained on maybe some programming related data, which contains maybe Python, Java, SQL, Rust, anything, HTML, PHP. So they will have the basic understanding, okay, what is the most usual sequence of the code, and they will be able to generate the next set of symbols, or in most technical terms we call them tokens. So if I talk about modern large language models, they are very large. They have so many, it's a very, contains very complex architecture or very big neural network, and they have been trained on large amount of data. So if I talk about these classic natural language natural language problems, entity extraction. Entity extraction could be anything. It is as simple, suppose you have any invoice. So your entities could be the date, the vendor details, GST number, amount, items, quantity. So these could be your entities. So entity extraction. Classification means text classification. Suppose you have newspaper, and in newspaper you have to classify news into different classes, maybe finance, political, entertainment, sports. So this is a text classification problem. Summarization, given a huge data, a huge document, you want to summarize it into some few sentences. Sentiment analysis, we all understand. Consider any IMDb data or maybe Twitter data, and we want to understand the sentiment, whether happy is one sentiment, sad, angry, neutral can be another sentiment. So sentiment analysis, translation, translating one text from one language into another language. So in class, these are uh, some few of the classic natural language problems. And before these large language models, we used to train a separate model for each of these problems. So suppose I want to do a sentiment analysis task. So what I need a labeled reviews. So these labeled reviews could be from IMDb. These could be your tweets, labeled tweets from your Twitter data. And the important thing is that these are labeled data set. That means for each review, you know that initially what is the review, means it's a positive review or negative review. Consider it as a 2-class problem. And once you have that labeled data, you can apply any supervised to the means it will be, the model will be able to learn for this particular sentiment analysis task. Okay, if you want to do classification, text classification, again you need a labeled, maybe suppose news data set. Then you do a supervised training, and then it could be classified into different classes. So labeled data set is a problem. So if I want to understand the language, which has so many complexities, one of the complexity is that I need to understand the context of the language. Suppose I say that I'm going to bank. Now, if I just say I'm going to bank, I don't know whether I'm talking about bank as a river bank or a bank as a financial institute. So it could be, so I need to know the next set of words also. So I need to go to bank to withdraw some amount. Then I know, okay, bank here refers to a financial institute. Or I can say, I need to go to, I'm planning to go to bank because I want to rejuvenate myself. So now I understand, okay, bank here refers to uh, a river bank. These kind of words which have different meanings in different contexts, these are called as homonyms. And there are other complexities as well in the language. And the traditional NLP systems were not able to, these supervised methods were not able to understand these different complexities because they were processing the text as a sequential information. So what we talk about today, if I talk about the current paradigm in natural language processing, you can relate it with a transfer learning. I'll talk about the transfer learning, but in transfer learning, what we already have a trained model, and then we can use that trained model for some. We can add few layers in that trained model, and then use it for different tasks. Okay, so if I talk about current uh, paradigm in natural language processing, we provide our model. Our model is trained with a huge corpus of unlabeled data. Okay, so here unlabeled data. If I give you a task that maybe at your home, maybe if some of you from a place, if I talk about my grandmother will not be able to understand Hindi properly. But even then, if I tell her that I went to that movie and I liked the movie in Hindi language, then also she will be, she has not been trained on sentiment classification thing. She is not that educated. So she don't know whether what is sentiment analysis task. She has not been trained for sentiment analysis task, but she will be able to understand whether I'm happy about the movie or I'm not happy about the movie. I like the movie or I don't like the movie. So we people, as human beings, we understand the language, and then if we have a good understanding of the language, we will be able to do classification tasks, we will be able to do sentiment analysis tasks, and so on and so forth. Similarly, these current the modern and the algorithms or the models, we train them on a large corpus of unlabeled data so that they understand the language, and then we can use these models, we can add some different layers to those models, and on a smaller data we can do some downstreaming tasks like sentiment analysis or other tasks. Okay, so these are some new paradigms in natural language processing. And this first step, this is called as pre-training, where we uh, uns- uh, use the unlabeled data to generate labels, and then use some supervised method to train the model later on. And this first step, where a huge self-supervised model was learned, these are called as large language models or the foundation models. Now let's talk more about these foundation models. So the core of these foundation models, whatever large language models you use, maybe ChatGPT, maybe Gemini, Claude, any of these models today which you use, or maybe before these generative models, if you have used BERT, all these models, the core of all these models is the transformer architecture, This transformer architecture was proposed in 2017 in a paper which is called as Attention is All You Need. And the major advantage is that that we were able to process a large amount of data because it supports parallelization and it understands contextual information as well. I'll talk about all these terms, but this is the major transformer architecture. It has two components, encoder and decoder. I'll first, if you have any doubts so far, just let me know. If I'm going too fast, please let me know and then we can proceed further. Any doubts so far? Okay, okay, thank you. So if we talk about transformer architecture, so before transformer architecture, we used to have sequential models. So recurrent neural network or LSTM, Groove. So what they used to do, so if they have to predict dot, they will see the previous words or maybe the next words which are closest to these dot. So these were sequential models. So for tot, it will understand the relationship between its neighboring words. So for tot, it will see its neighboring word, that is teacher, and the. Student, it will check its neighboring words, the and with. Book, but book, it will check its neighboring word, that is full stop, and left side it is the. So each word will check only its neighboring word. This is the case before transformers. But in transformers, each we check the relationship of each word with respect to all other word in the text. In this particular case, the teacher, it will check if I want to represent the teacher, it will use the correlationship between all other words in the text. Taught also, I will check its meaning with respect to all other words in the text. So it will provide me some information like who is reading the book and book is related to whom and other aspects of a language as well. So if I say, so book, these are more related to, taught is more related to teacher and student and book as compared to all other words in my sentence. So this particularly thing where we try to identify the correlationship of each word with respect to all other words in the sentence, this is called as self-attention. And this is called as my attention map. So if I say the is more related, here it is more related to teacher, here and the full stop, maybe. Teacher, if I say it is more related to taught, it is more related to book. Taught, it is more related to teacher, taught, and student. So if I say as compared to all other words, it is trying to identify the it is identifying the correlationship between all other words in the text and also checks which word has more or a stronger relationship as compared to all other words. So if I say student, student has strong correlationship with book, student, taught, and teacher as compared to all other words. Okay. So this is how it works. This is the basic idea of self-attention. How many, whatever number of words we have in a text, it will try to understand the relationship of each word with respect to all other words. The words which are more related to each other, they will have a stronger relationship as compared to rest of the words. So here teacher is strong. If I say book, book is correlated with teacher and student. Okay, as we can see here. So if I want to simplify this, so if I say this uh, architecture which was proposed in the paper, attention is all you need, there are multiple, this is my encoder block, this is my decoder block, and there are few things inside each of these blocks. This is multi-head attention, and here also we can see multi-head attention with some modification, masked multi-head attention. So if I want to simplify these architectures, so I can simplify it like this. They have two things: encoder, which takes input, and whatever is the output of encoder, that is passed to decoder. Decoder also takes some input and provides us the output. Let's understand this architecture in uh, in little bit detail. So suppose I have this input. The teacher taught the. Suppose I'm just considering these four words as of now. If I consider these four words, we all know that if I have to represent these words in computer, I can't represent it in form of a string. I need to convert them into some numbers. Okay. So this is my first step. I will divide my input into words. It can be words, it can be characters, it can be subwords. Generally, we don't divide our input into characters because then it loses the semantic information which a word contains. And we can divide the text into words or subwords. And then we assign each word a number. In a simplest form, let's consider that this number, I have a dictionary. And my dictionary contains, suppose, 2 lakh words. So suppose the comes at the 342 position in that dictionary. Okay. And I will provide that number to the teacher. This word teacher appears at the location at the number 879. And so I assign that position to this word teacher. Dot, it appears at the location or at the line number 432. So I assign it as this number. So these are my tokens. I'm calling them as tokens. So as I said, I can either use these words as it is. I can divide my sentence into these words. I can divide my sentence into these subwords. Why? What are the advantage of dividing these words into subwords? Because as we said that my dictionary contains lot of words. Now consider an example, teach, because it is shown here. So teach, so one is er, teacher. Teach plus ing, it is another word. So teach, teacher, teaching, and teached. I think teached is not a word, taught hota hai. But okay. And suppose I have similar word move, M-O-V-E. So I can divide that M-O-V as one subword and E as another subword. And then I can have move, M-O-V-E-R, M-O-V-E-D, M-O-V-I-N-G. So if I divide them into subwords, I can control the size of my vocabulary. Otherwise, the size of vocabulary will be huge. Okay. So now teach is one word. ER I can attach it with teacher also. I can attach it with mover also. I can attach it with pack and er packers maybe. So er can be added to other core words as well. Similarly, if I say ed, teached, moved, and joined, okay, so I don't have to separately save these words joined, moved, teached, and so on and so forth. Okay, so size of my vocabulary can be controlled. So there are different ways of tokenization, different type of models. If I talk about OpenAI's GPT, they use different tokenization method. If I talk about BERT, they use this is the same example which we have seen here, is the word piece tokenizer. So different type of models, they use different type of tokenization methods. So this is my first word. We have assigned a number to my words. Now, once I have once we have these numbers, I will calculate their embeddings. Embeddings can be considered as a vector representation. So each token I will calculate, I will represent it in terms of a vector. So in original transformers paper, the size of these vector, the length of this vector embeddings was 512. Okay, so I had these 4 words. I have assigned a number to each word, and then I'm representing each of these tokens in terms of a vector. Okay, uh, so there are different type of embedding model. Again, different kind of language models. If I talk about Gemini, they use different embedding model. Claude use some different embedding model. OpenAI, they use Titan, some other embedding models. And if I talk about uh, before transformers also, we had certain embedding models like word to vec, glove. So different kind of embedding methods can be used to generate these vector representations for each token. Original paper, as we said, that the length of these vectors was 512. What is the benefit of representing these tokens in terms of embeddings? Because when we are calculating these embeddings, they are also capturing the contextual information. So the words which are related to each other, they will appear. Suppose I have only I'm just representing each token or word with vector of length 3. So I can represent it in a these three coordinate system. Okay, so if I have each word is represented by a vector of length 3, then the words which are close to each other, they will have a similar or closer appearance in the embedding space. Okay, and we can get if how similar these two words are by by measuring the angle between these two words. So we have some cosine similarity methods by which we can say that okay, these two words are closer to each other, they are more related to each other. So embeddings also provide us some kind of similarity criteria, and these embedding vectors can have different values. So same student, if it is coming in different context, it will have different uh, embedding vector. Okay, so it depends on the context. Now one of the core idea or the major contribution of transformer architecture was that they can process, they are highly parallelized. So the each word can be processed in a parallel approach. So all words, if I have 10 words, I can process all 10 together parallelly. I don't have to do sequential methods like LSTMs or RNNs. So to have that sequential information, we add the positional encoding to these tokens. So if I have 4 tokens, I will have 4 position embeddings so that I know where these words are coming into my text. Then we have self-attention. What is self-attention? We have just checked that it will check the relationship of each word with respect to, it will calculate the similarity or the relationship of each token with respect to all other tokens in my text. And we don't have just a single head attention. We just don't have the one attention block. We have multi-headed self-attention. So each head, I can say, it captures some different attribute of a language. Maybe one head is capturing whether these two are homonyms. The one is capturing the relationship between different entities. So different aspects of language can be captured by different heads. So we have multi-headed attention. Then we have feed-forward network to provide some non-linearity. And in the decoder, we have softmax, which uh, assigns a probability score to all the tokens in my vocabulary and predicts the uh, out predicts the word which has the highest, which got the highest probability out of all the tokens I have in my vocabulary. So this is the basic architecture of transformers. Is it clear so far? Shall we move forward? So I have few questions. Just let me see. So what is encoder and decoder? So you can say that encoder is providing us some kind of representation for each of the tokens, each of the words, for each of the words in my input. Now, these representations can be used for text classification, for named entity recognition, and these representations will also be used by decoder for generating the text. If it is a maybe the text classification problem, it will be used to translation problem. It will be used to generate uh, the word in different language. If it is a code generation problem, it will be generating the code symbols uh, accordingly. So self-attention is not using argmax kind of probability. You can consider that they are calculating a dot product. They are just, if I have not gone into the details, but we have different type of matrices which are generated for each token, and we just calculate a dot product between different kind of these vectors. So more is, if the two words are more similar to each other, they will have a higher score as compared to the words which are not similar to each other. So kind of a dot product we use in case of in case of self-attention for calculating the attention scores. So if it is all good, can I move forward, or are there any other questions? Okay. So this is a overall architecture, like what are the different components we have in the transformer architecture. And what are these tokens and these representations, multi-head attentions, but how how I use these models. So let's consider let's consider my transformer as a sequence to sequence model. And now my task is I have to generate a code based on the question given by the user. So my input is write a function to print hello world message. And this is my output. Okay. So as we have seen, the first step here is we first do tokenization. So in this particular case, it can generate tokens like write as one token, a as another token, function as another token, to print, and it can generate 3 tokens for this single word hello world message. Okay, so I have first is tokenization, and then I will represent each of these token into a vector. Okay, using a some embedding layer. So I will have this x1 represents, you can consider it as a vector for the right, x2 it's a vector representation for a, and so on and so forth. And once we have the embedding, once we have these vectors, then we will concatenate positional embedding, and that will be my input to the encoder. And what is there in the encoder? As we have seen, encoder contains the self-attention block, it contains feed-forward neural network, and it provides me the output. Okay, the output of the encoder will be fed to decoder, where it will have some softmax output, and it will generate these results. Now let's again check how it will work here. We have already seen. So there is not only a single encoder block. What we have seen earlier, this was a single encoder block which contains a self-attention block, feed-forward linear layer, and feed-forward neural network. In general, we have many encoder blocks and many decoder blocks. In the original transformer paper, there were 6 encoder blocks and 6 decoder blocks. So this is my input. I create an embedding layer, add positional encodings, and then it goes to encoder, apply some attention, self-attention. It generates some output. It generates a vector for each input, and that will become the input for this block. Again, it will generate some output which will behave as input to this block, and so on and so forth. At the end, we will have a vector representation for each of my input token. Okay, and these vector representations will be passed to all the decoder blocks, which will later on generate the output. Let's see how it works step by step. We have already checked how encoder block works. So let's talk about the decoder part. In decoder also, we will provide, so in decoder, take use of encoder as well. Whatever is the output generated by the encoder, that is also used by the decoder. So, and what is the output of encoder? So output of encoder will be some representation. So write will have some output vector, and that output vector will contains the in contextual information, means how write is related to all other words in my text. Function, the representation of function will represent how this word is related to all other words in the text. So that will be the output of the encoder. Okay. In the decoder, we start with some dummy token, maybe the start token, and it takes the output of the encoder, and then it just tells the decoder that, okay, this is the start token, dummy token, and it generates the first output, that is def. Okay. Now this def will again be passed to the next decoder layer. So next decoder layer will contain this def, the token generated by the previous decoder. It will take that token. It will also take the previous token which was fed to the previous decoder and generate the next set of token. And this is called as auto-regressive generation. That means whatever output or token is getting generated, that is used as an input, and then next token will be generated. Whatever token we have generated, again it will be concatenated with the input tokens, and next the third token will be generated. So each step is generating one token, that each step is generating one token, and that token will be appended to my input to generate the next token. And this can go on and on until until the decoder generates an end token. So there are two dummy tokens. The one is the start token, which marks the start of the decoder, and end means no more token has to be generated. So encoder part, we could do all these things in a parallel manner, but for decoder, we have to, comparatively, it is one token at a time. So this is a summary of whatever we have discussed so far. Encoder, they encodes the input with contextual understanding and produce one vector plus per input token. So if I have 10 tokens in my sentence, it will generate 10 vectors for each token. And decoder, it accepts input tokens and generate new tokens. Okay. So different kind of language models were designed using this transformer architecture. There are some architectures which uses only encoder part of the transformer. So we have BERT, which only uses the encoder part, and since they are only using encoder part, and what encoder is doing, they are providing the contextual representation for each uh, token, for each input token. So they are used for classification. They are very good at classification tasks, text classification, um, sentiment analysis, named entity recognition. So encoder models are good at that. There are some encoder decoder models. Generally, so the original transformer paper, bar T5, they contains both the encoder and decoder part. Uh, right, these days, present days, we don't use them much, and whatever applications we see, like ChatGPT, Gemini, Claude, they are the generative models because they are only using the decoder part of the transformers. So decoder part is mostly responsible for generation of the text, and they are only using the decoder part. So if I talk about the GPT family, it is not that before 2022, when these GPT models became very popular, before that also, uh, smaller versions of these models came. But from 2018 to 2026 today, we see that these models have become bigger, and with better understanding of language altogether. So this is the first part of my talk, where we have understand the fundamental architecture of fundamental architecture of whatever LLMs we see today. So as per your application, you can choose either these large models And if you're suppose working on simple text classification problems, simple sentiment analysis problem, instead of using these higher models, you can also try these basic BERT models and fine tune them for your own application. Now let's talk about prompts. What do we understand by prompts and prompt engineering? So when we say prompt, so input which we give to the model, it is called as prompt, and the input plus the generated output by my model, it is called as completion. Here, one of the important thing which you have to keep in mind is this, which we called as context window or context length. Whenever you will go to a website, maybe Hugging Face, or maybe some other website where these model APIs informations are present or their weights are available, they also mention what is the context length for each model. So you should have, before selecting a model, you should also have the idea what do they understand by this context length. So the context length or context window, it is the number of text or tokens specifically which these models can process at a single time. Okay. So if I say in 2022, when ChatGPT came, the context window was around 4,000 tokens. 4,000 token means it was only able to process only 4,000 tokens at a single time. If I talk about today, the Gemini models and ChatGPT, their context length is around 1 million. That means they can process such a large amount of information altogether. Okay. Still, some of the small language model, they have small context length. So you should also keep all these things in the mind. Otherwise, and then design the algorithm. Otherwise, maybe some part of the information will be cropped and will not be used by the model, and it will only use half of the information to generate the response. And when we talk about these prompts, we also talk about a very important term here comes in the prompt engineering, is the in context learning. That if I say classify this review, I love this movie, and I write here sentiment. So I just want that what is the sentiment of the movie. So I'm just giving a idea to my model that what is my expected output. Classify this review, I don't want an elaborative response that these movie the or a complete sentence that this the review of this movie is looking good because you like this movie. No, I've just uh, told I've just told the model that I only want the sentiment. I've not provided any example. I've just provided the question and what is my expected output. Okay. So my model will generate positive. This is called as zero shot inference, that I have only provided the question and what kind of output I'm expecting. If I provide some example to my model, so if I provide one example to my model, it is called as one shot inference. So I say classify this review, I love this movie, and the sentiment is positive. The classify this movie, I don't like this chair, and then what should be the sentiment. Now model should use this information and will understand that user does not want happy, sad, angry kind of sentiments. It just wants positive, negative kind of sentiments. So using one example, it can generate the response. This is called as one shot inference. And similarly, instead of one example, if I suppose provide multiple examples to my model in the prompt, it is called as few shot inference. Okay. And in some of the cases, in some of the research papers, it has been so there is one more term which we have not discussed because it's a separate topic altogether. There is one term which is called as fine tuning. So fine tuning, consider it as a transfer learning only, that you have a trained model and you are so this trained model has been trained on huge amount of this has been trained on large amount of text, and it is able to do so many tasks. But for a specific application, you can have a small amount of labeled data and then fine tuned your model on that particular labeled data, and it works very well. But in this particular case, in fine tuning case, in some cases the model weights are also getting updated. Okay. So in few shot or in context learning, you are not updating model weights. You are providing the examples and model is able to understand from these examples like how it has to respond. And you can, even people have experimented, they have provided 20-40 examples and they were able to get good responses as compared to tuning. So instead of fine tuning, this is also a approach which you can look for getting the response as per your application. So this is the in context learning, and there is always a trade-off between the context window, because if I say context window, as we go from zero shot to few shot, we are using a larger, we need a large context window because we are providing so many examples also, and it can, so my model will take large amount, some amount of time in processing that information as well. But again, it's a trade-off between the time and the context window as compared and the accuracy. So if that is not a problem, if you don't have a problem of the context window, you can always add like more number of examples to explain your model, like what kind of responses are expected. And in and there was a paper in 2020 that they have said that as the number of parameters increases, as the number of parameters of my models increases, they become good, they become better in context learners, that they are just not memorizing that if this is the if this is the example, this is the output, they are not memorizing this, they are using these examples for learning in a better way, or maybe for the task for which they have not been trained earlier, but using those few short examples they were able to do those tasks as well. So here you can see that this is left side, it is showing accuracy, this is the number of examples, and these are the number of parameters in my model. So if I increase the, suppose these are 10 examples I provide, if the size of my model is very small, then adding more examples will not help. But as I increase the number of parameters in my model, my as I increase the number of examples, the accuracy of my model becomes increases a lot, you can see that. Okay. So larger the model, better is the they are better in context learners. There is one more uh, prompting technology which is very popular, and it is called as chain of prompting. So let's understand this with the example here. The chain of thought prompting, it was proposed by two different papers in NeuroIPS in the same year 2022. They both have proposed chain of chain of thought prompting. Okay. And what is chain of thought prompting? Suppose you are given this question, the model is given this question. that there were 10 friends playing a video game online when 7 players quit. If each player left had 8 lives, how many lives did they have total? And the answer is it randomly gives 80 as the output. But if I say that let's think step by step, this is the single sentence which you have to add. So now model will think step by step to solve this problem. It will first divide the problem, it will think about that problem, uh, and it will try to solve this problem in different steps. And when they using these steps, if they generate the answer, the answers are more accurate. Okay, so this is called as chain of thought prompting. And again, if we see, this is a benchmark, GSM 8K benchmark, which contains some middle school math word problems. And this palm was before Gemini. The palm was the LLM model on which they have experimented this chain of thought prompting. So as you see that with chain of thought prompting, the accuracy has increased a lot. Okay, so this is your blue one is your chain of thought prompting, and this black one is your standard prompting technique. Okay, and with chain of thought prompting, this accuracy has increased a lot better. Now, this chain of thought prompting can be combined with your in context learning. So there can be 0-shot chain of thought prompting, there can be 1-shot chain of thought prompting, there can be few shot chain of thought prompting. So for 0-shot chain of thought prompting, since we can't provide an example in provide an example, you just add a trigger. Okay, and what is the trigger? That let's think step by step. So it tells the model that you have to first divide, you have to think for the answer before generating the response. You have to divide you have to solve the problem in a step by step manner. So this is what it is has been done. First, LLM has generated steps or rational behind rational for solving this question. And once the rational has been extracted, it is able to generate the response. Okay, so this is chain of 0-shot chain of thought prompting by just adding let's think step by step statement. So it is adding a trigger. In few shot chain of thought prompting, you can write these steps. Okay, if I have to solve this particular math problem, this is how I can divide it into multiple steps, and now if I can get the answer. This is how I've written all these steps and the answer I have obtained. So rational also I have written, and the answer also I have written. And though so my model will also work in a similar way, that first it will write that rational and then accordingly generate the response. So this is my few short chain of thought prompting, and this is very popular even with all your models these days. They use these techniques now. Most of the time you don't even need to you can also, like, if you're planning to do anything, uh, you can tell your model that don't generate the response, only generate the plan. So you can see that how, like, if you're writing a particular prompt, is your model able to understand that prompt properly and able to generate plan accordingly? If you think that yes, model is able to generate plan appropriately, then you can tell model to use that plan to generate the response. But if you think that model is not able to generate the rational properly, it also a trigger for you that you have to write your prompt or the question properly. These days, we say that we have very advanced model. uh, Even if you're not able to write these prompts properly, they will be able to understand it. But what we say today is that we do context engineering, that if you provide a context to your model, they will be able to generate a better rational and better answer. So besides writing the prompt in a specifically to your model, some ways is that you can also provide a context to the model. What can be the context? Like if you want to get if you want to use these models for maybe a simple task, for maybe generating an email for you, so you can tell about that, consider yourself. uh, you have to set a persona, that you are a working professional, or maybe you are um, maybe business analyst, and based on these business use cases, you have to generate a response. So you can provide a context and model will be able to get, and when you are providing the context, this rational part gets improved and your answer gets improved. So these are the results which was published in Neuroip's 2022 paper, where they compared uh, chain of thought prompting with zero shot and few shot examples. So this is GSM 8K, which is your basic school mathematics, and this is also mathematical multi-step mathematical calculations, and on all these in both these benchmarks, if you will see that uh, the chain of thought prompting has given better result. So this is zero shot chain of thought prompting, but if you have added few examples, the results have improved a lot. Okay. And if I say we were talking about fine tuning, where the gradients of model gets also changed, but if you will see, with few short examples and chain of thought prompting, the results are comparable or even better as compared to this fine-tuned model as well. Now, since this workshop's basic theme is agents, uh, I want to talk about one more type of models, the reasoning models, which became very popular in the late 2024. And because of these models, we are now able to design all these agentic applications. So what are these reasoning models? They are popularly called as LRM, large reasoning models. Instead of just large language model, they are called as large reasoning models. That they uh, change the plan, and then they generate the response. Whatever response they are generating, before showing it to user, they keep on thinking on it, do self reflections. If they are not satisfied with that, they will modify it, they will correct the response, then check whether the response they are planning to generate is correct or not. Once they are satisfied with multiple iterations, then they will give the final response. And these models are trained using we called as reinforcement learning method. But there is one method which is very popular for before reasoning models. We used to have reinforcement learning through human feedback, RLHF, reinforcement learning through human feedback. You must have seen many a times when you are asking any question from ChatGPT or Gemini, they produce two output and they generate two responses, and they ask you to select which one you prefer. And based on your response, they train their model that which is the preferred output. This is called as reinforcement learning through human feedback. Now, in reasoning model, there are some kind of verifiable rewards. Generally, these are complex mathematical problems where after having a proper plan, they know what should be the final output. If the results are correct, they on the basis of the result, whether they are correct or not, they uh, again retrain their model. Okay, so that's how they these models are learned. And if you see these reasoning models became very popular in 2024 with OpenAI O1 preview, Gemini 2.0 flash. These all are called as thinking model. So in ChatGPT also, if you ask that do a research and um, look for uh, proper sources by which and present the verifiable information only, then you many a times you also see that they show a tag which called as thinking. So they take time, but they these models are called as reasoning models, and they are correcting themselves, and when once they are satisfied, they generate the response. So this we have plots on it. This was in 2025. In 2026 also they have Opus model. The current the Claude code, which was a breakthrough and came in January, February, and now in recently in April, Claude code. They all are using those Opus models, which are high, very good thinking capabilities models, very good reasoning models. And you can always see like whether this is a reasoning model or not. So the chat GPT says thinking for 5 seconds. You can also if you are in a pro version of chat GPT, you can also enable thinking. And many a times it does not show you the complete thinking process, but if you are using the API keys, and if you want to see what are the what the model is doing at the back end, what how it is reasoning about certain things, you can look at the complete text what is going at the back end. But these models should be used only when necessary, when a deep research is required, because though we can't see, we are only able to see the final response, but at the backend, many the tokens which are being generated at the time of thinking, they are also being calculated when the final the cost or the output token cost is calculated. Okay, so use these models only when required. So Gemini also, after 2.5 flash, recently we have 3.1. So all they have the thinking capabilities. And recently, not recently, but in late 2025 and in sorry, in early 2026, they are all are proprietary models. Okay, so if you want to use them in your own application, you have to pay for the API keys and all. But there are some open models also which have these thinking capabilities. So these models are Quinn, uh, 2.5, recently 3.5 has come. There is Gemma 4 model. So the Gemma 4 model has thinking capabilities, plus they can be they are open models, means if you want to design some applications, they have Apache free license, which open source license, which you can use in your own application. So so that is all from the basics of the prompt engineering and the architecture of transformers, which I want to share. I also want to give you a small demo, like if you want to design an application and you want to use some A keys and write the prompts, how you can design those applications. So I want to give a demo of it. But before the demo, if you have any questions, I can take those questions. So any questions? Is anybody here? Any questions? Am I audible? Okay. Thank you so much, Vidhi. Okay. So suppose I have just I'm just sharing a small demo. Like if you want to write prompts, how you can see whether the prompt which you are writing is correct or not. You first want to check those prompts. So they you can you may also want to decide whether you want to use Gemini API for a particular task. Maybe you want to Claude or maybe ChatGPT. So one way is go to these web applications, write your prompts and check the result. The another is, suppose you want to test your prompt and also want to get some starter code. Most of the time we don't know how, from where to start, how to get the API keys, where to put those API keys, how to write the which packages we should import or include in our program. So there is a platform by the Google, which from where you can use where you can get the API keys of Gemini, Gemma, which is Google's open model. You can also get the API keys of Gemma, which is Google's vision language model. Vision language model means kind of a multimodal, but they are uh, fine tuned for basic image understanding tasks also. Like if you want to segment a particular image, if you want to identify a particular image, want to generate a caption, then you can use these vision language models. So Gemma is one of those models. So you can get the APIs of all these models on the AI Studio. I'll show you all these things. So here I'm showing you how to generate a Gemini API key. It's not only Gemini API key. Once you generate these API key, it can be used by any of your Google-based model, whether it is Gemini, whether it is Gemma, whether it is Gemma, anything. Okay. So I'm showing you a demo of Invoice Manager. So generally what happens if you're working in an industry, so you have Sodexo or Pluxee kind of application where if you submit the bills of your petrol or maybe driver, you get some kind of tax benefits. And people like me and most of us are not very active at submitting those bills as soon as we get them. Generally, we wait for the year end uh, or maybe at the month end to process and to submit those bills. So, if you want to maintain a record of all the shopping you have done, or maybe all the shopping or fuel, I want to make a record of all those things. This is application which you can. Okay. So let's first start with how to get this API. So I've written here Gemini API, but it is Google API, means you can use any Google model using that API key. So you have to go to this website, http aistudio.google.com. Okay. Once you go to this website, here there's so many things you can try to generate images, which is otherwise in Nano Banana it is you will not get pro model, but sometimes they provide you some free tier. You can use this in free tier mode. Okay. And mine is pro version, so it is available for me, but it is available for you also. So here you can test your prompt. So I have given one invoice image, and I have given the prompt in a few short, one shot manner. I've given one example. So I have just said that you are provided with the invoice, give the date and total amount from the receipt. give the response in the following JSON format. I have created a JSON format because then it is easier for me to save it in a Excel file. Okay, so if here I have shown an example of one invoice, but otherwise I have kept all the invoices in a particular folder, and I have created an application where my model will read all the images and create a JSON list of JSONs for all the invoices, and this list I can export directly in form of Excel file. Okay, and I have given some example that image ID is January 2025. So in the invoice itself, date is written, and it has to use that date to create a image ID. Then date is it has to provide date in this DDMMYYYY format, and amount it has to enter like this. Okay, so here I have provided a one example like how my model has to behave. Once I write, so here I can write my prompt, and here I can select the model. So in this particular case, I am using Gemini 3.1 flashlight, but if you will click here, you will find multiple examples. So if I show you, if my screen is visible, just let me know. So this is, so here you can get so many models. So these are my Gemini models.
Screen
Out
is
of,
visible, but it's not looking proper. It's slightly blurred. So, can you
because
reshare it?
uh, is the feature of maybe the Gemini Pro, because I am sharing some information, I am sharing certain screen. So due to security concerns, it is hiding that
Not because
information.
of that, ma'am. Even in your presentation, it was happening in between. So that's why
Okay,
the
okay, okay, okay. So
resolution is
let me
slightly
just,
low. So maybe you can turn off your video for some time and then continue. That is also one more.
okay, okay, just. Is my screen visible? Is my screen visible now? Okay, thanks. Uh, so can you see the model selection part here? Okay, no. So you can try it on your own. Means I'll show you the where you can find it. Let me show you on PPT if it is visible. So is my PPT visible? The slide deck visible? Can someone please unmute and say? Okay, thank you so much. So you can see Gemini 3.1 flashlight. So if you will click here on this aistudio.google.com, you will find multiple models. Okay. And you can also see here it is saying thinking level. So we just now we have seen that there are large thinking models as well. So by default it is minimal because extra tokens will be used, and sometimes in simple applications I don't want that kind of thinking because it adds the latency. It takes the time to respond. Okay. And most of the time I don't need that kind of thinking in my day-to-day tasks. Okay. So but on aistudio.google.com, if you can click, if you can open it on in your laptops right now, you can change that thinking level here. Instead of minimal, you can change it as per your application. Okay. And so you can choose the model, you can choose the thinking level, and you can get the API key from here. So if you will click the API key, you have to provide it a name and just follow the process of, and you will be able to create the API key. Once you have all done, maybe you have checked your model prompt as well. You want a starter code from where you can begin, right? So if you will click here, you will get some starter code also, and you can do some modifications in that starter code, and you can design your application. So if I I'm just test, if I just entered like given this input to my model, this is the JSON it has created for me. Okay. So in my invoice, the amount was 1,000 only, and this was the okay, so it has created a JSON. Now I have once you have the API key, okay, so collab.research.google.com, and in the left hand side you can see that there is a key icon or thumbnail is there. When you will click on that key thumbnail, you can uh, give a name. I have given it Gemini key because it's you can also
Maybe your screen
name
is
it as
not
Google
properly
key.
visible. Sorry, we can't see
Okay, okay,
anything.
that's fine. I don't know why
If
it is
possible,
happening.
if possible, can you change your Wi-Fi to some other connection?
Yeah, just yes,
That
just
will be
let me.
better because it's happening frequently.
Yeah, okay, let me do. Um, just let me know, please. I'm so sorry for all this. Is my screen visible now? Um, is my screen visible now?
Screen is visible, ma'am, but it's still blur. Let's wait. Now it's clear. Let's continue for some time. At least your voice is coming, so we can continue. Yeah.
Okay, yeah. So I'm just saying that if you can open your collab.research.google.com, is it still blur or you're able to see some text here?
Still blur, ma'am.
Um, so so I'm sharing actually the link of the collab notebook in the chat so that you all can go to this collab notebook. So somebody is saying that it is visible now without any blur, anything. Are you able to see the screen now without any blur? By zooming the content, okay. So you can go to this. I've shared the link of the GitHub repository. So there you can find the Google Collab notebook if it is visible to you now. Yeah. Here you see if zooming helps. So I'm just saying that if you can click Google, go to Google Collab, and here on the left side you will see a key. You whatever name you have, you want to provide a name, you just name it. I have here written Gemini, but you can use Google key as well. And the API key which we have generated from aistudio.google.com, in the value just you paste it. Okay. And here it's a complete code. So what I have done, in my drive I have created a folder invoices which contains all the invoices, the picture of all the invoices. I have kept I think 12-13 invoices, and then the complete code is written. So the code here, it is also checking whether the same image ID I have used or not. Maybe I don't want to process the same invoice twice, so it is just checking whether I'm processing my invoices multiple times or not. So there are some additional helper code written in the collab notebook, but if you will see, the important components are written here, that I need to import some packages. uh, then some parameters I have to specify to my Gemini model, some temperature, top P, top K values. And you can also specify the maximum number of tokens you want to generate. I want the output only in form of text. So I have written here response mime type. If you want to generate image, here it will change. Okay. And the temperature, it controls what is the degree of randomness in your output. If it is a higher value, one or more than one, then every time the model will be more creative. If it is close to zero, it will be more deterministic. It can't be deterministic, but yes, the output will be um, not too much random. Okay. So these are some of the sampling criteria. Like you can check it further, but higher the value means I want to select the highest those tokens which has highest probability. You remember we have provided some softmax probability at the decoder end. So this is what is the probability. So we are using 40 such tokens. We are considering 40 such tokens which have the cumulative probability of 95, and out of those tokens we will be randomly pick any one. Okay. And this is the model. It's a old code, so here it is written Gemini 1.5 flash. You can use with Gemini 2.5 flash. One advantage of using Gemini 2.5 flash is that though the Gemini is a paid model, but in free tier also you get some requests. You can make some requests per minute free of cost. Earlier it was 20. These days Google has reduced it to 5 calls per minute. So maybe you can add some sleep or some waiting criteria so that you don't exhaust the limit. And there is some 100 requests per day which you can make to this model. And this is the image. So I'm reading this image, and I'm just here. I've given a simple prompt, but in the Collab notebook, you will find that exact prompt that in the proper JSON format, it will generate the response, and then the complete JSON will be saved in form of an Excel file. Okay. So these are the some helper codes. You again the same link I have provided you in the chat. You can go to the link and you can try the code on your own. So this is all from my side. These are some of the resources which I have used for creating this PPT. If you want, I can also share these resources. I'm putting these resources in the chat. So if it is still blur, you can go to these resources and check it yourself. So that is all from my side. I'm extremely sorry for this blur and these technical glitches. The Wi-Fi is not coming to our institute today. I don't know why. So I am using my mobile data, and I really apologize for all the inconvenience. But if you have any questions, I would be happy to take those questions.
Thank you so much, ma'am, for the nice session. So some of the participants have questions, so we will unmute them, we'll make them panelists, and then they will be able to ask the question.
Sure. Okay.
And if possible, ma'am, I request you to share your slides so that participants can
Yes.
revise afterwards.
Yes. I will. Yes, I will definitely share the slides.
Thank you, ma'am. And session was extremely good. Now, I guess all the participants know how LLMs work. That was the core objective of this session. So you have explained nicely regarding transformers architecture. That was the key part, apart from prompt techniques. And the last segment, of course, participants will be able to recreate because you have already shared the link. Thank you for that.
Yes. Yeah. Thank you.
Yes,
So
Pradeep
if you're
Kumar,
not
you
able,
can go ahead and ask the question. Yeah, Pradeep Kumar ji. Yeah.
मैम मेरा क्वेश्चन ये है, अगर मैं मान लो अपने जैसे मेरा कोई ऑब्जेक्ट डिटेक्शन का केस है तो मैं उसको एलएलएम से इंटीग्रेट करना है मुझे, सो इन दैट केस हाउ शुड आई
देखिए
प्रोसीड?
ऑब्जेक्ट डिटेक्शन केस जैसे जो कुछ मॉडल्स हमारे होते हैं विच आर गुड एट लैंग्वेज रिलेटेड टास्क. So I have told about some of the models which are good at these tasks like object detection, image segmentation. मतलब आपको ऑब्जेक्ट को डिटेक्ट नहीं करना, आपको सेगमेंट भी करना है. तो उसके लिए आई एम राइटिंग वन मॉडल, इट्स पालीजेमा. तो instead of normal Gemini model, in the aistudio.google.com you can find this Pali-Gemma model which will be good at this object segmentation and detection task. Yes, YOLO is there. So YOLO is a deep learning model, but if you want to use these vision language models and these multimodal models, you can definitely try this Pali-Gemma.
मैम कैन वी इंटीग्रेट योलो आल्सो विद पैलिज्मा?
No, YOLO is a different model, different architecture, and this models are different architecture. These are entirely vision language model which are designed for some specific image segmentation or all these things. How you can, if you want to combine this, so in the coming sessions, I am hoping that you will be having some agentic related. So using those agentic related sessions, you can ask your agent to maybe call YOLO model, but using these, this is not the task. So as we have seen earlier, the language models, they're good. They're good at general. Okay, they can't call and run some other model. So they can generate tasks, they can understand the language, they can generate the content, they can understand the content, but they
one more
cannot run
question.
the code, they cannot call any other model.
Ma'am, one more question.
Yeah, please go ahead.
How we can introduce
Yes.
human in loop in this object detection case? Which will be
So
go either
human
to
in loop. So
the
this is
ma'am,
yeah.
that will be
So
go in the case of
human
the
in loop.
bounding box cases or maybe classification side.
So human in loop, it's again not related to the language model or YOLO. This is an application specific thing. So before giving the final response, you can trigger some human response. You can show the response to a particular human, and then as per the feedback, you can save that output. But it is not related to means it you can look at be any application, not LLM based application, not just YOLO based application. It can be added in any FD application.
Hello, ma'am.
Okay,
Good
thank you.
afternoon.
Yes.
Yeah,
Good
ma'am.
afternoon.
Yeah, the whole transformer model which you have explained in a very well manner, that is will be based on the probability theory, okay? But every answer
Yeah.
or the things which may be partially true or something. So my question is, in place of probability, can we use the fuzzy logic in any stage of the transformer architecture?
See, in the transformer architecture, if I talk about specifically about these models, the big models, if I talk about these Gemini models, and these are proprietary models, so I don't know how many encoder layers are there, or how many billion parameters are exactly there. The only thing is that I can use these models. I don't have any access to the core architecture component of these models.
No, for
So
the
these things are
reasoning,
completely hidden.
yeah, but for the reasoning
So
purpose,
for fuzzy kind,
fuzzy
for
mathematics.
fuzzy kind of things, yeah. So this is what I'm saying. For the fuzzy kind of thing, you can add these fuzzy logic on the top of the output which you are getting from these models. Okay, but you cannot uh, modify the architecture of these models as such.
Okay.
Once you get
So,
the response, then you can add some fuzzy logic. Yes.
okay. So at the transformer level architecture we cannot do, but we can fine tune using
Af-
RAG model and all, and then we can incorporate the
yes,
fudge
yes.
to minimize the
Yes. So
something,
whatever
improve the
evaluations we are
quality.
doing, yes, right. So whatever evaluations we are doing and whatever we are doing, so we are doing on the top of the responses we are getting from these models.
Okay. So what type of things improvement we can do by applying this thing?
So there are so many
Like in
things,
answers.
um, like we haven't the right now the model will provide the response only based on the knowledge. So we have seen that these models have been trained on Wikipedia pages and English textbooks and so on and so forth. So these models have the knowledge cutoff. So they have been trained maybe on the data which was available till 2022. So if you want to ask some questions which are specific for maybe your company, for your organization, then RAG based approaches can be used. If you want to use these applications, these models for getting some real time information. Maybe you want to perform some stock price prediction and you want to get some real time data, and you want to read some real kind of data, then you can use some APIs. You can write your own functions as well. So these are the external tools which we provide to our LLMs, and this is the concept of agents. I think that will be there in your coming sessions.
Okay, thank you.
Yeah, you're welcome. So there is one question like any threat detection model. So one thing want to like make it very clear that maybe I'm not aware of any threat detection models, but yes, we use these models for finding vulnerabilities in softwares. So they are good at understanding the language. So wherever you think that they are good at understanding the question, understanding the content or understanding the text, there you can use these models. But specifically, we don't have any specific large language model or multimodal model which can directly be used for threat detection. You have to use these models for a specific task. You have to fine tune maybe, or maybe you have to provide some external examples, some kind of tool, some APIs, and then it can be used for threat detection. But directly, no. Any other question? So there is one question like how can I build a chatbot? So generally, when you need to build a chatbot, this is for a particular maybe organization for particular application. So generally, we add some kind of RAG-based approach for designing chatbots. The GitHub link which I've shared. So if you will go to that GitHub link, notebook for RAG or for with Chroma DB. So there you can check the code for.
Sorry to ask you again, थोड़ा सा इंटरप्ट था वॉइस में। एक बार जो आंसर आप
हाँ
किया
जी
था एक बार वो रिपीट कर दीजिए बिकॉज के वो प्रॉपरली मैं सुन नहीं पाया था, आवाज नहीं आई थी। मेरा जो इंटीग्रेशन वाला क्वेश्चन था एक बार अगर
योलो
जी
वाला
मैम,
ना।
योलो मतलब मेरा ये है कि अगर मैं इंटीग्रेट करना चाहूँ तो विच काइंड ऑफ द मॉडल आई कैन इंटीग्रेट?
देखिए मैं ये बोल रही हूँ कि जो हमको ये समझना पड़ेगा दैट जो ये लैंग्वेज मॉडल्स होते हैं या आज के टाइम पे मल्टी मोडल मॉडल्स होते हैं जो लैंग्वेज इमेजेस ऑडियो सब समझ सकते हैं, दे आर जनरेटिव मॉडल्स, मीन्स दे कैन जनरेट द टेक्स्ट। तो ये ना ये योलो को कॉल कर सकते हैं डायरेक्टली, ये लोग को कॉल कर मतलब दे कैन अंडरस्टैंड कि हाँ इसकी नीड है कि मुझे कोई योलो या ये मेरा सेगमेंटेशन मॉडल है, बट दे कैन नॉट रन द मॉडल। और वो उसको कॉल कैसे कर सकते हैं वो आपके आगे के सेशंस में आएगा व्हेन यू विल टॉक अबाउट एजेंट्स, राइट? सो उन एजेंट्स में होता है कि गिवन एन एप्लीकेशन, अब नीड है कि हाँ मुझे कुछ इमेज सेगमेंटेशन का टास्क है एंड आई हैव दिस योलो मॉडल एंड आई कैन कॉल दिस योलो मॉडल, तो दैट कैन बी डन। बट डायरेक्टली अगर मैं किसी एलएलएम को बोलूँ कि योलो मॉडल कॉल करो तो अभी वो नहीं कर पाएंगे, मीन्स दे डोंट हैव द एक्सेस फॉर दैट योलो मॉडल। सो इन एजेंटिक एप्लीकेशन यू विल गेट टू अंडरस्टैंड कि अगर आपकी कोई कुछ इस तरह का क्वेश्चन होता है या एप्लीकेशन होता है, देन यू गेट अ चांस, देन द मॉडल कैन सी अ नीड एंड देन द एजेंट कैन रिक्वेस्ट फॉर दैट योलो मॉडल।
मैम मेरा जैसे क्वेश्चन ये था, फॉर एग्जांपल मुझे डिटेक्शन करना है सर्टेन उसका ऑब्जेक्ट का, So first I should go for
हाँ
the LLM to find the detection, and then I can
नहीं
integrate the
नहीं
result with. Is it possible?
सी तो देयर इज अ पालीजेमा मॉडल मैंने लिखा था यहाँ पे, अगर आपने देखा हो तो मैंने फिर से चैट पे डाल दिया है।
Okay, ma'am.
तो तो aistudio.google.com पे अगर आप जाओगे तो वहाँ पे आपको ये पालीजेमा मॉडल भी मिल जाएगा, व्हिच इज गुड एट बेसिक ऑब्जेक्ट डिटेक्शन रिलेटेड टास्क। जैसे अभी हमने फ्यू शॉर्ट एग्जांपल्स देखे थे, इसमें हमने सिर्फ एक इमेज टेक्स्ट का एग्जांपल देखा था। सिमिलर फ्यू शॉर्ट एग्जांपल्स कैन बी डन विद दीज मल्टीमोडल मॉडल्स, जिसमें आप इमेज और टेक्स्ट दोनों डाल सकते हो। एंड देन यू हैव टू ट्राई दैट आउट, बिकॉज वो कुछ ऑब्जेक्ट्स तो डिटेक्ट कर लेगा, बट वो सारे ऑब्जेक्ट कितनी एक्यूरेसी के साथ डिटेक्ट करता है, दैट यू हैव टू चेक।
Okay, ma'am. Thank you.
या मोस्ट वेलकम।
Hi, madam. I'm Abhinav. Thanks for the nice
या हेलो,
session.
थैंक यू सो मच।
Madam, I have a question related to in-context learning and chain of thoughts prompting.
या
These
प्लीज गो
two,
अहेड।
yeah, these two methods will only have temporary effect, correct? They won't change the model weights or model parameters.
No, they will not change the model weight.
So the effect will only till that session.
You can say so, yes.
Yeah. Is there a way that post training do we have any method post training which will have effect even for the long term, maybe not just limited to a session?
So for that, we have some methods called as fine tuning. So we have different fine tuning methods.
Okay.
So that can be done.
Okay.
But
Fine.
if you don't want to, fine tuning, I'm just writing it in the
Yeah,
chat
yeah,
again.
I have heard about that, but fine tuning will change the model weights as well.
Yes.
Okay, great. Thank you.
So there
Yes.
are multiple ways. One way is it will change the entire weight. And
Mhm.
another way of fine tuning is that you have like LoRa. So it
Mhm.
just add some additional layers so that your complete model does not change. And some
Okay.
additional layers can be added, which
Okay.
will be responsible for the specific task for which you are fine tuning them.
Oh, great.
But again, I would say that fine tuning, it's computationally expensive process.
Mhm.
So अगर मैं आज के मॉडल्स की बात करूं, अगर if you are using you will be reading about these agentic applications, right? So today agentic applications, we have like term called as agent skills. I'm writing it in the chat, you can
Okay.
read about it.
Sure.
So agent skills, ये आप whatever task you want to perform, if it is अगर आप उसका पूरी planning and everything you can specify properly, so you can store that planning and everything in this agent skills, using this agent skills, and it will be there. Means this is a file, and if this so model will read this file, it will understand the context, it will understand how it has to proceed. So
Okay.
if this can be, again, it's a application specific. If you need to change the weights, अगर कोई मॉडल है ही नहीं जो आपका एप्लीकेशन के अकॉर्डिंग इट इज एबल टू वर्क, देन फाइन ट्यूनिंग इज वन वे. But if you think that okay, you want to just provide some specific instruction for your model, some use cases, you some even you can store these few short examples as well, so you don't have to provide these few short examples again and again.
Okay.
So that can be stored in these agent skills, and the model will read these agent skills and work properly. It also saves your context. You read about this, and I hope this will be of agentic applications.
Okay. Great. Thanks for the very good answer. I mean, very elaborate answer. Thank you.
Thank you so much. Yeah.
Okay. Thank you so much, all of you. Now we'll move to the next session because we don't have much time. Thank you so much once again, Anukruti ma'am, for your wonderful session.
Yeah, thank you so much for the opportunity. It was great interacting with everyone. Thank you so much.
Thank you, ma'am. Okay, so now we'll take break for just 2 minutes in order to start the YouTube session, and then we'll start with the second session of today. I hope